Welcome to Chemistry Solutions with Steve. This is a GCSE Chemistry revision for limiting reactants, and it's for the higher tier only. It comes from section 4.3, which is all about quantitative chemistry. So what is limiting reactants all about? Well, in a chemical reaction involving two reactants, a reaction finishes when one of the reactants is all used up. And it's common to use an excess of one of the reactants to make sure that all of the other reactant is used up. The reactant that is not in excess and therefore completely used up is called the limiting reactant because it limits the amount of the products that you can make. So, the reactant that is left over is described as being in excess. The mass of the product formed in a reaction depends upon the mass of the limiting reactant. And this is because no more product can be made when the limiting reactant has all been used up. And this is a very, very important idea in the chemical engineering industry. Now, limiting reactant questions are very similar to reacting masses, and there's a general method. Step 1. Work out the number of moles of the substance for each reactant. Use the ratios of moles in the balanced equation to work out which reactant is the limiting reactant. Use the ratio of moles in the balanced equation then to convert those moles of limiting reactant into moles of a product, and then you work out the mass of the product, and this is done using our Mr. Moles with a mass on his head formula triangle, which you may have seen in my previous videos. So, let's have a look at an example of a limiting reactant. Here's the reaction between magnesium and oxygen. It's one of those you've done in science loads of times, I am sure, where you get the brilliant white flame. So, look at this here. 2 Mg plus O2 goes to 2 MgO. 48 grams of Mg react with 40 grams O2, which is the limiting reactant. So we only need to consider the reactants, which are the Mg and the O2. First thing to do, write down the mole ratio, which is 2 magnesiums to 1 oxygen. Then down the left-hand side, we put mass Mr. Moles. And then we can fill in the data from the question. 48 grams of magnesium are used in the reaction. Mr, or Ar in this case of magnesium, is 24. So to get the moles, we use our Mr. Moles with a mass on his head triangle, and we do 48 divided by 24, which gives us 2 moles. Then we do likewise for oxygen. So we've got 40 grams of oxygen in the question. The MR for oxygen is 32, which comes to 1.25. Clearly, the number of moles of oxygen, according to the ratio, should be 1, but it's now 1.25, as we've just worked out from the mass of 40 grams of oxygen. So there's a greater amount of oxygen than there should be, so therefore the oxygen is in excess. If it's the oxygen that's in excess, it must be the magnesium that's the limiting reactant. That's just by definition, and we can see that there. So to answer the question, magnesium is the limiting reactant. Okay, let's have a look at a more challenging problem. 2.7 grams of aluminium are reacted with 9.125 grams of hydrochloric acid. Part 1. Which is the limiting reactant? And question 2. What mass of aluminium chloride is formed? The equation is 2Al plus 6HCl goes to 2AlCl3 plus 3H2. So, pause the video, have a go and see how you get on. So the first thing we're going to do is convert the mass of the reactants into the numbers of moles using Mr. Moles with a mass on his head. We jot mass Mr. Moles down the left-hand side and then the two reactants at the top. We're using 2.7 grams of aluminium and 9.125 grams of HCl, hydrogen chloride or hydrochloric acid. The AR for aluminium is 27. Using Mr. Mole's triangle, we cover up the moles and we do mass divided by the Mr. 2.7 divided by 27, 0.1 moles of aluminium. We've got 9.125 grams of HCl, so we need the MR for HCl, which is 1 plus 35.5, that gives you 36.5. 9.125 divided by 36.5 comes to 0.25. Now we look at the molar ratio, the actual ratio from the equation. And we can see here 2Al reacts with 6 HCl. So that's a ratio of 2 to 6, but we have to simplify that to 1 to 3. So for every 1 aluminium, 3 hydrogen chloride, 3 HCl. So if we compare this to the question, 0.1 moles of aluminium would react with 0.3 moles of aluminium. Now from the masses that we've worked out from the moles from masses, we've only got 0.25 moles of hydrogen chloride instead of 0.3. So the HCl will run out first. Therefore, it is the limiting reactant. So let's consider the second part of the question. What mass of aluminium chloride is formed? Once again, pause the video, see how you get on. To calculate the mass of aluminium chloride, we must use the moles of the limiting reactant to calculate the mass of the product. So remember, use the molar ratio between the limiting reactant and the product. So that ratio taken from the equation is 6 HCl gives 2 AlCl3. Now we have to simplify the ratio just to make it a bit easier. So 6 to 2 as a ratio simplifies to 3 to 1, and then we simply get rid of that 1. We don't put 1s in equation. Now looking at the actual moles of HCl used, that's 0.25. So the moles of aluminium chloride made will be 1/3 because it's a 3 to 1. For every 3 HCl's, 1 AlCl3. So we multiply 0.25 by 1/3, and that gives us 0.0833 moles of aluminium chloride. Calculate the mass of aluminium chloride by using Mr. Moles with a mass on his head triangle, where mass is the number of moles times the Mr. We'll work out the Mr of aluminium chloride. That is 27 plus 3 times 35.5, and that comes out at 133.5. So the number of moles, 0.0833 times the MR, 133.5, gives us a final answer of 11.1 grams if we round to 3 sig figs. Okay, thanks for watching. I hope you feel more confident with limiting reactants now. And there are more calculation revision videos in the playlist at the end of this video if you click the right boxes, etc., the links. Or if you fancy a GCSE exam paper walkthrough, there's also a link for those as well. See you next time.